Hey everyone, welcome back. Today I'll be going over question number 13 on the Webassign. This is for Hires Webassign Chapter 2 Part 3, and yeah. So a lot of you have had questions with number 13, and yeah, for good reason. It's one of the hardest questions on the Webassign, if not the hardest. But it can be solved much in the same way as question number 11, which I covered in a previous video. Essentially, you have to solve for, it doesn't give you enough answers to use kinematics to solve immediately, so you have to use a system of equations to solve it. So here, what you do know that the time it takes for the stone to drop at 9.8 meters per second squared acceleration from 0 meters per second to the bottom, and the time it takes for the sound to come back the entire length at 343 meters per second constantly is 1.52 seconds. So to find the time it takes for the stone to drop, you just subtract the amount of time it takes for the sound to get back up, which is delta x over 343 because like distance equals time times velocity and whatnot. So this is constant velocity. And you'll find key through here. Now, what I wanted to do, I guess you could have done a different approach, that would have been a little faster in retrospect. But what I did was then I isolated delta x by, just isolate delta x algebraically, and you'll get delta x equals 1.52 times 343 minus 343 t. But now you can use the delta x you would find from a kinematic equation from one of the ones in the notes and solve. Now you're looking for a kinematic equation that has delta x and t, where you can solve for delta x and t is the only thing you don't know. In this case, I just use a fifth kinematic equation, and since we know initial velocity is 0, it simplifies out to delta x equals 4.9 t squared. Now you realize both of these delta x's are equal to each other. So by extension, this and this should also be equal to each other. And then you can basically use systems of equations to get this to a single equation, a single quadratic. So 4.9 t squared plus 343 t minus 521.36 equals 0. And then you can just solve for it using quadratics, or binomial theorem, whatever that's. I don't know the name of that. Anyway, you'll find that the time that it took for the ball to drop is only 1.488 seconds instead of the full 1.52. Because the very small amount of time left over is the amount of time it takes for the sound to get back up. And now that you know time, you know enough things to solve for delta x. And you can just plug it in back into one of the kinematic equations. I just used number 5 again, which states delta x equals vt minus 1/2 at squared, which simplifies out to 4.9 times 1.488 squared. And if you solve all that out, you'll get delta x equals 10.85. So thanks for watching, everybody, and if you have any further questions, feel free to leave a comment and whatnot. Alright.